Inverse kinematics of robot manipulators. We are going to start with an introduction to this topic. So for kinematics, we have a robot and we have some joints here. And we also have some frames, for example, the frame of the end effector and the frame of the base. The objective of kinematics is to establish some relation between joints and the pose, which is the position or orientation of some point. For example, we might want the position and orientation of the end effector frame with respect to the base. So when we deal with kinematics, we have two things, this joint space and the operational space. Forward kinematics consists in giving the joint space and finding the operational space. So it is, given a joint configuration, finds the position and orientation of some part of the robot, for example, the end effector. That is, given this set of cues, it finds the position and orientation, which can be given by this homogeneous transformation or by this expression, which is exactly the same. For example, this x can be just a representation of position in Cartesian coordinates and a representation of the orientation using, for example, rolled geo angles. We also have inverse kinematics, which is the opposite relation. So in inverse kinematics, we have this. We want to find the joint configuration needed to achieve a certain position or orientation for some part of the robot. So given now this transformation or given this general representation, we want to find the joints. Let's consider a simple example, an RR robot, which is this one and which we have seen already before. Let's deal only with the position of this robot. For the position, we can consider Cartesian variables like x and y. And in this case, we have two joint variables, which are these joints, q1 and q2. Forward kinematics establishes a relation between these two elements. So as we saw before, we can geometrically establish that x, the position here in x of the end effector, is going to be L1 cosine of q1 plus L2 cosine of q1 plus q2 using simple geometry. And the same is true for y, but changing cosines with sines. So this in general can be established as this one. X equals a function of the joint space. That is, given q, there exists a single x. Inverse kinematics is the opposite. Now in inverse kinematics, we want to find q's, and we have x and y. So the problem is what comes here? What is the expressions? What are the expressions that we need here? The problem now is q equals the inverse of x. So given x, does there exist a single q? Let's see an example. This is a Stanford manipulator, and as we saw, the end effector with respect to the base can be given by an homogeneous transformation matrix, which represents position and orientation. Each of these elements is given by these elements, which are a combination of cosines and sines, as you can see. The problem of inverse kinematics now is the following. We have to compute the angles, the q1, q2, etc., to achieve, for example, this pose for the end effector. Take into account that this is a numeric matrix, these are numbers. So in the previous expression, we have to use the equations and make the elements be equal to the values shown in this matrix. Now the problem is that, as I said before, you have a lot of sines and cosines, and so it's a system of nonlinear trigonometric equations, which is not easy to solve. So in inverse kinematics, we want to find the joint angles. Given a desired position and orientation for the end effector, we find the joint angles. It is a synthesis problem because in this case, we want to achieve a certain position. It's not analysis anymore. The input data is the position and orientation, and it can be of this form, the classical formulation, which is a homogeneous transformation matrix, or it can be a generalized formulation where the first elements represent the position and these three last elements represent the orientation. It is a nonlinear problem. So since it is nonlinear, we have to ask ourselves some questions. Is there a solution? Is there a unique solution or multiple solutions? And the answer will be the workspace and the redundancy. Another question is how to solve this. It is not that straightforward.